So thank you everybody for joining us today. We have an ETRO U topic requested from the pre-construction team on the Internet of Things. So Jeremy has been working in this industry and in this specific field for quite a number of years and has tons of experience, and he's happy to assist us on this topic. So he's going to cover some of the big things that we need to know, as well as some of the troubles that he's seeing out on project sites and where we as ETRO can be prepared for the Internet of Things. Thanks, Jeremy, and you can now take control of the screen.
Excellent. Thanks very much, guys, for the opportunity. I had a presentation put together, but I think it might be a little bit high level, based, especially with the amount of time we have, to address more of the construction related issues. So I'm going to dig in, starting with IoT, or myself, Jeremy Cooper. My consulting group, Cooper Hospitality, works with connected sensors, which predominantly works in IoT water leak management, which is by far the most accepted and widely used of IoT devices that are out there. And then we also do a lot of hospitality and design for all kind of technology systems for buildings throughout. IoT is a very broad term. I think it relates to anything connected at this point, from a thermostat to an air quality sensor, even through to DDC and different kind of control systems. So you could have a thermostat. You have a thermostat obviously to control your fan coil unit in your room. That thermostat would report as an IoT device, so control and monitor and manage by monitoring. Okay, well, if someone's cold for heat in that room, the fan's been blowing for the last 2 days, but it's trying to achieve that temperature. In a typical sort of a dumb unconnected thermostat, that could go on forever. So you imagine the amount of energy that could be wasted by that not being connected, some kind of analytical engine trying to find that fault, right? And imagine that in a hotel, for instance, across 300-400 rooms, with a percentage of them having these faults. Even blowing hot and then really trying, because the filter hasn't been changed, so that extra energy used to try to achieve that result. So by monitoring, having an IoT device, for instance, like a thermostat, and this sort of applies to generally to all connected devices, being able to monitor and understand that system. So if it's calling for heat, the fan's blowing, we can see that on the front end. Is the fan coil pulling cold water through? Is it pulling hot water through? What's happening on the other end, which would result in another IoT device, some kind of temperature sensor, for instance. So as an example, a smart watch is also an IoT device, very different, but it's learning a person, right? Learning a person, a demographic. It understands what that person is doing in a day and how they live their life, and understanding the body of that person, and then categorizing it. And you imagine you times that by millions and millions of people. All of this data creates a smarter workout plan, or a smarter way of achieving some kind of medical feat, right? That data from anywhere you can get it, it creates a smarter building, a smarter application, and it really goes across any industry. There's a company, Labellium, from Spain. They're one of the pioneers in creating sensors in these networks. And they apply it to so many things. I actually had a video, but it would take up a lot of this time. You think about agriculture, and that doesn't directly apply, but I'm just trying to illustrate that point of IoT, where it's just data gathering. Having an understanding of the soil, right? The temperature in the soil, the moisture levels in soil, in various locations, understanding the pH balance in soil, understanding the weather for that year. All of this data can make farmers so much more intelligent and not so reliable on, I guess, god of controlling that environment, right? So you can be a lot more proactive rather than reactive. And I think that really sums up what IoT is for, is being proactive, understanding and measuring risk and be able to address it before it happens, changing that filter before you blow something in that fan coil unit and have to replace the fan coil, the sealing, paint, all of that fun stuff. And that essentially is IoT. Does that make sense to everyone? Anyone have any questions? All right. So part of, oh no, did someone raise a hand there, or was that just a thumbs up? I think that was just a thumbs up. All right. So me being from Connected Sensors, part of Connected Sensors, I've been working with them to try to make IoT devices operate and be pragmatic in construction or an occupied building. I'm sure all of you are so aware of technology. It was birthed as some propeller head thought, wow, this is great. This is going to be perfect. It can apply to all buildings, all scenarios. But when the rubber hits the road, it doesn't really apply, or it doesn't meet the standards, or, oh, I didn't think about that, right? The first thing is connectivity. So there are a lot of different types of connectivity. So from sensor to a gateway. So a gateway translates the site to the cloud where it can be analyzed, or site to a server that may be on site, which performs the same function. That can be LoRaWAN, which is the most widely used, Sigfox, even Wi-Fi. But I think you're going to learn more about LoRaWAN in the field these days. It can go through anything. It can go over 19 kilometers in open air. They've had instances where they tested LoRaWAN from a satellite, and you could get a ping from the ground level. It's pretty incredible. Through buildings, it doesn't go that 19 kilometers. It goes more along the lines of, depending what's in front of it, you could go 100 meters, and that's through concrete, through steel, different variables like dishwashers and fridges and things that are added to a site throughout that process. So the sensor to the gateway, that's the initial communication. There are varied different types of communication. You're probably going to run into LoRaWAN more often. And then from there, it's connectivity. So I think most companies, IoT companies, would say, "Oh, we can do it cellular." And it probably 90% of the buildings we've tried to use cellular at, they don't work. It's spotty at best. You need a wired connection, a wired internet connection. It's a big problem out there, that connectivity. There's only so many variables you can address with connectivity in a drawing or pre-construction. And when you need connectivity like a network in a construction phase of a project, it creates a bit of a problem, right? So how do you get connectivity for these sensors during the construction phase? Are you able to get network? Are you able to get a cellular router that would communicate cellular out, but have it wired network within the building? So I think it's not addressed enough. People, they sort of phase over that, gloss over that quite quickly in the early stages in the design phase. So my recommendation is to always try to do wired where possible. Always, even if it's cellular from the roof down, so you have wired connectivity and you can manage it accordingly. So we have the sensor to the gateway, gateways throughout the building, usually in some kind of equipment room where there's network, or like a riser, a technology riser obviously would be the best, or an electrical riser. And then you that's how they communicate out to the world. The other part, which I'll focus on water specifically. So this is people can see it, a water leak detection sensor. So it's a LoRaWAN sensor, and it can be stuck to a a wall or any kind of surface, and then it has an adapter that collects the data and pushes it through to the sensor where it communicates, say, LoRaWAN to a gateway, and then puts that information out to the cloud or to a server where it can have a cause and effect, right? The placement of these, in most cases, when I started at Connected Sensors, they'd look at a set of drawings and they'd say, okay, a sensor's got to go here in a fan coil unit. Being birthed in a lab somewhere that really has no idea of construction and what really happens out there, it was put on a page and sent, and it was approved. And 3 years later in construction, they say, okay, it's supposed to go on the fan coil unit, but it's actually a horizontal fan coil unit, and it's in the ceiling in the middle of the room. So how do you place that, right? How are you going to place it and achieve that use case where you're trying to detect water, right? If you put it on drywall, then is the drywall going to absorb that water? If you put it in one area, is it going to, where's the leak? Where is it likely to happen? So you really have to get down to that granularity to understand and not be caught off guard. The other thing is in risers. So the most frequent position, especially water leak, is on riser. They could be in the wall. Sometimes they're in party walls where it's a firewall, fire rated shaft, excuse me. So, if you don't do that ahead of time, then you have a sensor that's sitting on the wall. And how do you get into that wall? How do you make it effective by having the actual sensor within the wall? Even in kitchens and things like that, having it positioned in a spot where practically it's not going to get knocked off or abused. It's going to be able to communicate out to the world, to the gateway, and then off to the world, and be effective throughout the life cycle of the sensor. The same goes for air quality. If you get a designer to design you air quality, they're going to put these devices, they're going to place them on the drawing. And it may not apply unless it goes through that standard cycle through all the major consultants. In IoT, being much like technology in early days when, computer systems and networks, it was left to the last minute. No one really reviewed it. We've got to add power. We've got to add this and, conduit, raceways, things like that after the fact. Most IoT sensors will apply in the same way, where the location isn't considered. The specialization of IoT providers are mostly about the sensors, so they're just plotting them on a drawing, and it doesn't get considered throughout that, as any other system would likely if it went through that typical construction process. Does anyone have any questions about that? All right. So the other part of IoT, is that cause and effect, right? So what do you do with that data, right? What do you do with that? Okay, there's a leak. It can rather be a detect and notify kind of scenario. If there's a leak, if there's over a certain level of VOCs, volatile organic compounds. So in the air, if there's, for instance, in a laundry room, in a hotel, they might have a high, of chemicals in the air, right? And most people don't really know it. It can go on for a long time. But what do? Do you pull the fire alarm and everyone run out of the building? You can detect and notify, and are people really going to adhere to those messages, and who really gets them? And then what do you do then, right? With water leak, it's very early days, and a lot of people will give you that notification, and they don't want to take responsibility at that point. In other cases, for instance, in construction phase, you'd have the sensors in the risers where applicable, where they're full of water, and you could notify a valve, a controller near the main valve coming in, the main domestic water feed, and shut off the water. So you sort of mitigate further damage. And it's always best efforts. Like you think about how much water is sitting in those pipes. If you cut off at the main water feed, that the rest of that water, especially if it's being pumped through the building, is still going to come out on the floor somewhere. So in all aspects, it's always a best effort. You can have, controlling pumps throughout, depending on the phase of construction or the occupied phase. So you can control through the DDC, which most IoT companies I'm finding aren't doing. They're not leveraging the DDC. They're not leveraging any kind of controls. They're trying to install their own redundant controls, which are wireless and unreliable in almost all cases. The problem, we don't have enough data. And the only reason it's going through right now is we don't have enough data in the industry to say, well, this worked, this didn't. People aren't watching it enough to say this worked, this didn't. But if you already invested in a DDC and the phase of construction you're on, it's a simple API. So it's a sort of a network integration that will, you can communicate quite easily between those two systems, or even a dry contact. So, open, close, leak detected, open, let power through, and that will let the DDC create a function to shut off pumps. This was detected on the domestic water on level 2. Shut off the main, shut off a PRV station. You see, that logic can be put into the DDC where it's already connected, saving yourself, in some cases, $100,000 in network and connectivity and controllers, and also leveraging the specialty of controls, which has been, vetted and beat up in the industry for forever. IoT is very new. The sensors are good to communicate a small yes or no, 1 or 0 to the cloud, and then relay that command. Having that control on the other end is very early stages. And like all technology, the contractor wants to do it all and wants to say they can do it all, but there aren't the standards in place to control it. With network cabling, for instance, it was just a free for all, 20 years ago, just going every which way in a ceiling. There was no standard in which way. This is how you do it, right? This is how it should be dressed. This is how it should be run. It needs to be away from large electrical sources. And then you have a standardization, just like there is for mechanical and electrical and everything under the sun. IoT hasn't gotten there. So mitigation of issues and problems with these systems is trying to leverage existing building systems to have that effect on the building, if that makes sense. Are there any questions about that? All right. Well, are there any other questions about construction? That's something that you guys have run into that you'd like to ask before I go on? No? All right. Well, I think you're going to run into leak detection more and more. And I think a lot of the trigger for these things is going to be things like insurance. We have, with connected sensors, more projects. The vast majority of the projects are initiated by insurance. So insurance says, thou shalt put this kind of system, which they have no idea really what they're talking about, but they say that these are the guidelines you need. So when the system is installed, they can say they've done that. They've taken this step to mitigate damage, and their premiums would drop. In some cases, you can't really get insured without it. it's the damage with the number one damage in construction, insurance claims is absolutely water. There's a flood or there's a pinhole leak that's just been trickling away for months, and it's just gathering on each floor as it goes down the riser, affecting everything in its path. It just sort of everything swells. It can be really bad in places like Edmonton. We worked on a project where they had radiant heat around the perimeter of the building. And obviously when it drops down to -40, the joints expand, and they've had millions and millions and millions of dollars in damage, where they've gone to contract for a water leak detection worth $1 million. So it's actually become quite substantial. Without the standardization to really control a lot of the on how it's implemented. So yeah, I think. Oh, go ahead, Karina.
Yeah, it's not really a question for you specifically, but I know a number of our projects have leak detection because it is an insurance requirement for us. So we haven't standardized our solutions. Each of the project teams has been going and finding solutions for those. Is there an advantage to standardizing across the company, or what do you think is the best approach?
Absolutely. There's with sensors. I always say this when I'm explaining that it was birthed in a lab. These people make these sensors, but they don't understand construction and where it's going to go. And there's even at Connected Sensors, which is one of the bigger ones in the industry. The early, they operated for 3 years without having really any construction knowledge in it. But they're starting to learn. There's companies that will say, here's the sensor, have a nice day. You have the cloud and everything's there for you to configure your own thing, because they don't want to have to manage that, because it is hard. It's a sensor and a gateway, and it seems really easy, but there are unlimited amount of variables that need to be addressed before construction, before the drywall goes on 100%, because you want to have it in the wall. Access hatches, is it fire rated, is it not? Location of access hatches, accessibility, is it going behind, in a laundry room, for instance, was a frequent position. Standardization will make that so much easier. I think the industry will catch up and provide that standardization. So, interchangeable sensors, protocols, network connectivity, but right now they don't. So standardization from the sensor, the full solution, understanding a network of all of these things are speaking. If you have, for instance, Quadreel, they're really pioneers in this. So they have a lot of different sensors. If you have LoRaWAN, you have Wi-Fi, you have all of these different things speaking, or maybe two LoRaWAN systems, there can be interference. And there's not the detection or the systems out there, the test devices that there is for network, for instance, now to really diagnose effectively. And you just leave the client throwing their hands up in the air, and it ends up being a paperweight to them. It really needs to be thought of thoroughly, the whole ecosystem, ahead of time, to be able to make sure that everything's been considered and addressed. And I think, yes, standardization is the only way to do that in the near term. I think so. The industry will catch up, though.
Cool, thank you. And I know we have a couple of Quadreel projects, so
Yeah.
project teams might have questions for you.
Yeah, it's interesting, and it's an imperfect science, and even at best, it's best efforts. If water leak detection, you can have it in every floor on every riser, controlling every system, shutoffs at the domestic water feed into every suite. But it's this infinite amount of money. So it's a best efforts, right? And again, there will be standards that come out, and Quadreel has a playbook, for instance, and this is what they expect, and this is what will address their concerns, mitigate their concerns, right, or their risk. It's all about risk tolerance and budget, obviously. But I encourage and welcome, you know, at any time, anyone can reach out to me. Happy to discuss it in detail. I have 20 years in construction. 10 of those have been related to IoT and external systems, and the previous 10 were electrical and network distribution. So I have a lot of insight. I've made a lot of mistakes. I've made all of them, hopefully. So I really know. I've had a lot of experience in what's right, what's wrong, and the problems that we run into.
Great. Do you have maybe a slide with your contact information on it so that?
You know what? I have a slides with all of that information. I just went, but I don't have my contact information. I'll send it to.
Yeah. Send it
I'll
on
send it
over
to
and I'll
you.
distribute it to the team so that they can all contact you directly. And yeah, I encourage you guys to reach out to Jeremy with any questions. He is at the moment in our office, but he does have to run for another meeting. But if you wanted to pop down and say hi and ask questions offline, feel free to do that as well in the next few minutes.
Awesome. Well, thanks for the opportunity to talk to you guys. Appreciate it.
Thank you, everyone. Have a great day.
Thank you, Jeremy.
Bye.